Hi, good afternoon, everyone. I'm Yinkai from Southern University of Science and Technology, and I'm here to present Underactuated Robotic hand with linear trajectory based on work linkage mechanisms. So I will introduce my project for four categories: background, design, grasping experiments, and conclusion. So first is the background. Usually for end effector, we have two categories, the dexterous hand and also underactuated robotic hand. The dexterous hand control each degrees of freedom by one actuator, while the underactuated hand control for fewer actuators, which make for fewer control or similar control. So for underactuated robotic hand, we usually have three kinds of grasping mode: the parallel grasping mode, the coupled grasping mode, which is simple for our human fingers, and also self-adaptive grasping mode. And for a specific parallel grasping mode, and we can see that the robotic Q hand, when it's grasping, it will have a curve for the curve trajectory for the end effector. So it might be fail for grasping some plate objects placing on the ground. So we are trying to solve this problem by finding a linear mechanism to overcome these issues. So then we found work linkage mechanisms. So work linkage mechanisms is a 4-bar mechanisms. Usually, it will have a specific ratio of link lengths. And so by doing the simulation, we found that during the specific range, the end trajectory point E is approximately linear. So based on work linkage mechanisms, we have the design of our hand. So the grasping process is like this. So we generally have two actuation gears. So first gear and second gear, and each gear have a block, first block and second block. Initially, the two blocks is contact together. And so our actuator will actuate the first gear to rotate. So the first block will leave the second block. And the first gear is connected to the proximal phalanx via the torsional spring. So the proximal phalanx will rotate, which will perform a linear parallel grasping mode. And there are two cases. One case is our distal phalanx just contact with the object. So we finish grasping. And another case is our proximal or middle phalanx touches the object. So it will be fixed. But interesting part starts. So we have a torsional spring to connect to the proximal phalanx. So even though proximal phalanx is fixed, our first gear will continue to rotate until the two blocks contact each other and push the second gear to rotate. And the second gear is connected to the second linkage, which is parallel to the distal phalanx. So this rotation of second gear rotation will cause the rotation of the second linkage and also cause the distal phalanx to rotate over the distal axis, which will make it possible for adaptive to the surface of the object. So this is called adaptive grasping mode. And based on our design concept, we have a demo, and we have checked for linearity and checked for grasping ability, which shows simple control, underactuated, and linear trajectory for distal phalanx. So for conclusion, we have designed an underactuated robotic hand with both linkage mechanisms, and which is capable for two grasping mode, and a single motor control, which is underactuated, and its dual functionality. And the advantages: versatile, cost-effective, and adaptive grid sprints, which is suitable for use for industry area. Okay, thank you.